rightly told by Ritesh also, that 15th September every year we commemorate birth anniversary of Sir M. Visvesvaraya, and who is considered to be the greatest engineer of India. In fact, he was a civil engineer and he received Bharat Ratna also. And the prominent work, if we see of Sir Visvesvaraya, that include the development of dams. Even he was a great statesman also. He, in fact, developed the State Bank of Mysore, and he also developed Dam Krishna Raja Sagar Dam in Mysore. And in fact, Bangalore Agriculture University, that was his contribution, and he also set up Government Engineering College and many more works to his credit. And the day is not only meant to give tribute to pay our tribute to Sir Visvesvaraya, but rather it is also to encourage the people to appreciate the work of the engineers and who have contributed to the development of this country. And the day also reminds us of this engineers not only from one field. In fact, engineers from all over, whether it's from mechanical, aeronautical, chemical, computers, so many fields of engineering, they all have contributed to the development of the country. So the day is also meant to accomplish the contribution made by all these engineers in accomplishing the goals the country is looking for the development. And India today has emerged as a leader in the IT industry, and just because of our hardworking software engineers. And IoT, if we talk of it, has the workshop we are organizing today, Internet of Things, that really has gone, I should say, in the modern era. If we talk of the engineering, it has really played a great role in the revolutionizing the country. Rather, it has shown us to live with how to live and work smarter. And it has also, in fact, it has given a complete control over our lives. And further, if I talk of the career opportunities in this field, and currently you will see that there is the development we have seen, the opportunities we have, the career opportunities we have never seen in any other field till date and never before. And in addition, I should say if we talk of today the automation, or we talk of the even the farming community, if we talk of the whatsoever the development which has taken place in times to come, our farmers are going to be benefited by these kind of developments. And today we have with us Professor Sharma, Anurag Sharma from GNA University. I welcome you, sir. And in fact, he's going to talk to you about all the fundamental concepts of cloud computing, wireless interfaces for data transfer, and potential of the IoT in real-time applications. So, not coming in between you and Professor Sharma, I would once again welcome you and welcome you all. And over to you, sir. Thank you. Thank you very much for being with us.
Thank you, sir. Thank you so much, sir. Thank you, sir. So first of all, I would like to thank you, Vishal sir and Pathak sir, for having me here. So as you rightly said, that IoT is one of the most emerging areas nowadays, right? It's not about IoT. It is a combination of, sensors, actuators, cloud, data analytics as well. So it combines a number of protocols. It combines a number of technology. It's not a single technology. So first of all, I like to thank all of you for having me here. So I hope, Vishal sir, we can start.
Just before the start, I would like to share your brief profile with the students.
Right.
Dr. Anurag Sharma is doctorate from Dr. B.R. Ambedkar NIT Jalandhar in the field of artificial intelligence for healthcare. His MTech and BTech from Punjab Technical University Jalandhar. He has more than 15 years of total experience in teaching as well as in industry. He is primarily working with GNA University as professor in Faculty of Engineering, Design and Automation. He has published more than 80 research articles in reputed international journals and conferences. So this was the brief profile of Dr. Anurag Sharma. So over to you, sir.
Thank you, Pathak sir, for this great, description of mine, right? So let me share my screen, then we'll start with our today's workshop. So I hope my screen is visible to everyone.
Yeah, it's visible.
Thank you. So first of all, happy Engineers Day to all the engineers and budding engineers. So this is a very important day for every engineer. So on this auspicious occasion, we are here to have a workshop on Internet of Things, right? So as directors has already elaborated about IoT, that there are a number of profiles required for IoT nowadays. So as the name signifies, Internet of Things. So earlier it was Internet only. Nowadays it is Internet of Things, or there is another terms also, Industrial Internet of Things also. So that means things are interconnected with each other without any human intervention, right? So this is our today's agenda. It's not about only IoT. We'll talk about cloud also. We'll see the practical demonstration also. We'll see the application future and what kind of a hardware we can have for IoT devices. Now, if we see during the COVID time, so this IoT has been, market has been expanded, because, you can see that delivery of groceries even through the drones, even all the things, all the devices, they are having RFIDs. So when we are talking about smart cities, when we are talking about smart devices, so IoT plays a very significant role. So in this 1.5 or 2 year or 2 hour presentation or workshop, I'll try to go through various aspects of IoT. I'll give the introduction of IoT, how it works. Even at an end, we'll have some hands-on also using Node MCU. So first start with what is IoT. So for many people, there are different number of definitions of IoT, and all those definitions are true, right? So as IoT, it is a scenario where objects, people or animals are provided with unique identifiers. Now, this is the main thing. As we already, if we know about, like in mobile phone, we are having IMEI number, or in, you can say, devices, laptops, computers, we have a MAC address. So that is a kind of a unique identifier, right? So when we talk about IoT, the main thing is that every device, every object, people, or maybe if you're talking about animals also, there should be some unique identifier, so that we should recognize to whom we are sending, from where it is coming, right? And with its ability to transfer data without human to human or human to system interaction. So that is the one major definition we have, that there cannot be, or there may not be, any human to human intervention, and there should be some unique identifier, right? So it is a machine to machine interaction. So in other words, sometimes we may define IoT as a combination of embedded networking software system used to put information on cloud and assess it in real time without human to human or human to computer interaction. So there are a number of definitions we can have. We may see other one also. IoT is an arrangement of physical electronic components with an applicable software combined with network connectivity, which enables a system to collect, share, and analyze the data, right? So basically, if we have to, tell a layman that what IoT is basically, so IoT is nothing. It is, interconnection of sensors, then processing elements, that network interconnectivity, and then we may have even analyze the data, right? So what we do, we sense the data first. We send those signal, maybe it is in analog in nature. Analog means it is a real time, that at every point of time we have some value, right? So we process that data, we convert that data into digital form, we transport that data or transfer that data to the cloud. So when the data is on cloud, right, we'll also elaborate about cloud in coming slides. When the data is on cloud, that means we can see it from anywhere in the world, right? For example, if I'm sitting here in Jalandhar, let's take an example that I wanted to monitor some patient who is in, say, hospital here in Jalandhar. Say some doctor in US wanted to monitor the blood pressure, the heart rate, the temperature of that patient. With the help of IoT, that doctor can monitor. So how it works basically, with various sensors like blood pressure monitor, with temperature monitor, with ECG, with EEG monitoring, that data would be captured, right? And that data would be sent to some, microcontroller, and then through, so Wi-Fi it would be onto the cloud. And through cloud, we can even watch that data, view that data, and even we can analyze that data. So that is one, you can say, application of IoT. So there are enormous applications of, IoT. So again, there is one more definition of IoT. Things in IoT sense can refer to a wide variety of devices, such as heart monitoring implants, biochip transponders, farm animals, automobile with built-in sensor, DNA analysis for environmental, food pathogen monitoring, or field operation assistance that assist firefighting, search and rescue operations. So things can be anything, right? So it may be people, it may be animal, it can be objects also. So these devices collect useful data with the help of various existing technologies and then autonomously flow the data between other devices. So that is, basically interconnection of IoT. So in years to come, or maybe within months, there may be, like, we are moving towards smart cities. So there would be, interaction between two cars also, between car and traffic lights also. Let's say if there would be interaction between cars, that to maintain a safer distance, right? So IoT is having, a number of application. We'll later on discuss the applications also, right? So this is, I wanted to throw some light on the history of IoT as well. So this concept, it is not very new, right? Yes, the name IoT is new for all of us, but the idea came into picture in 1999 through Auto ID Center at MIT, right? So during some research of market analysis publications. So there was a initial state, there was RFIDs. You must have seen that RFIDs. When we go to hotels or restaurant, they give you card to assess that, doors. So that is radio frequency identification. Based on radio signal, we identify that whether that person is authenticated to open the door or not, right? So that is, you can say, the beginning of IoT, right? So RFID was seen as prerequisite for IoT at that point. RFID is nothing, but it is a kind of a, identification between two devices to authenticate each other. If all objects and people in daily life were equipped with identifiers, computer could manage and inventory them. Obviously, as I told you earlier, that if everybody is having some unique identity, for example, in a classroom, we distinguish students through usually roll numbers, right? In a university or in an institute, there are, that identifier is roll number, that we can differentiate student or year or class through roll numbers only, right? So in real time, if we'll identify, it'll give some identifier to different objects. What we can do, we can manage them, and or even we can inventory them also, right? So besides using RFID tagging of things may be achieved through NFC, there is another technology, barcodes. I hope you must seen QR codes also, different Wi-Fi mechanisms, Bluetooth mechanism also, right? So that was a brief history of IoT devices. So now quickly coming to how IoT works, right? So I must tell you that there is no particular protocol for IoT. I hope audience must know what is a protocol, right? So protocol is nothing but it is a, you can say, rules governed by both the parties which are involved for data communication, right? For example, if I'll tell you in a layman language again, that in a university, we always follow some kind of a rules that, so there will be a timetable that from say 9 to 4, we should be into the university. From 9 to 10, we have a class. From 10 to 11, we have a class. Maybe on Fridays or Mondays, we need to wear a uniform, right? And this is a fee structure. We need to pay a fee by this time. So that means universities having their own protocols and you need to obey that protocols, right? So similarly, when we talk about IoT, there are number of multiple protocols. IoT itself, it is still till date, it is not having a particular protocol. It is a, you can say, combination of various technologies, various, you can say, protocols, right? So IoT is not the result of a single novel technology. It has several complementary technical development provide capabilities that taken together to help a bridge between the virtual and the physical world, right? So these are some components. I'll elaborate in the next slide. So this is the structure of IoT, you can say, system. So the lot can be viewed as a gigantic network consisting of network of devices, computers connected through a series of intermediate technologies, right? So first thing is like tagging things, as we have already discussed a number of times in this presentation. That first task is that there should be some kind of a unique identifier, right? So real-time item traceability and addressability by RFID or say barcodes or through some QR codes. So first thing is, which is important, that every device should have a unique identifier, unique identity over the network. Why? Because if there would be not any kind of a unique identity, for example, if I'm sending a data from say my location from Jalandhar to say Delhi, so if there would be no location, no channel, then it would be mix up with the other channels or other data, right? So feeling things. So the first one was the tagging things. The second was feeling things. So feeling means, for example, in a human body, we have different sensors, right? We have nose, we have eyes, we have ears, we have tongues. So what is the prime function of all these sensors? Like if we have to taste, tongue is there. If we have to hear some voice, ears are there. If we have to see something, eyes are there. So similarly, depending upon the application, we should have sensors, right? For example, if I wanted to monitor say moisture in the earth, so we should have that moisture sensor. If we wanted to have a sense the light intensity, there can be a LDR. That is, even I'll show you today the practical also on LDR, right? So light dependent distance. So there are number of sensors. Like if we talk about healthcare, right? Because I work with healthcare, right? My BTech students, MTech students, PhD students, they are working along with me as a team, right? It's not a kind of a, you can say, teacher and student relationship. It's a team relationship where I learn from them, they learn from me. It's a mutual one, right? So we usually work with healthcare. So we are currently working on like say smart jacket for health monitoring systems. We are working with brain control devices that with the help of only by thinking you can control the devices, right? Through ECG signals. So these all are signal. Like ECG is a kind of electrocardiography signal where you can sense your heartbeats, right? There is a signal from your heart which is captured through ECG sensors. Similarly, from brain, we have a EEG signal, electroencephalography. From muscles, we have EMG signals. So our body even itself generate different types of signals, and there are sensors available for it, right? So that is one example. So the third main technology is like shrinking things. We are moving towards, nanotechnology. Earlier, it was, a bigger component. Let's say we have transistor, which is having a size of, say, one mug or one bottle. We can say we could have a computer like which is of the room size. So with the advent of technology, with various researches, various interventions by the engineers, right? So we are in the era that we can have like small cameras. Even in mobile phones, you can see there are 3 cameras, which is in even when pens we have cameras, right? So that means how it is being possible with the research only. Now we are having a nanotechnology which makes devices very small in size, right? Then thinking things, embedded intelligence, AI, right? So I hope you all must have heard about AI. So AI is nowadays in everywhere. If we talk about, say, embedded intelligence, nowadays devices are so smart. Even let's say, even if I have to shop something through Amazon, right? They will check your keywords, or if you speak on mobile phone, right? They capture your voice samples say I wanted to buy an iPhone 14, right? They will capture your voice, and by the very next day or within the same day, you will get ads of on Insta or Facebook regarding iPhone, right? So that is the power of intelligence. So say when we say artificial intelligence, so as the name signifies, artificial intelligence. So as a human, we have a natural intelligence, right? So researchers, what they are doing, they are producing machines which are smarter enough. Those machines can take their own decisions, right? So that is a kind of artificial intelligence we have, right? Here in IoT, again, we utilize embedded intelligence in devices through sensors, and they has formed the network connection to the internet. So these all are the main, you can say, intermediate technologies through which IoT is possible. So that's why I was saying that it is not only a one technology, it is a combination of, you may say, number of technologies. I hope I'm audible, loud and clear, and my screen is visible. Anyone?
Yes, sir, visible.
All right, sir. Thank you. Just a minute. Now you can see that same thing I have represented pictorially, right? That RFID, then sensor, that smart technology, nanotechnology. Initially, I'll show you the practical of this also, right? So first, try to understand what is the structure of IoT, right? So RFID, so it can be RFID, it can be QR, it can be other mechanisms also to identify and track the data of things. Sensors to collect and process the data, to detect the changes in the physical status. Smart tech to enhance the power of the network by devolving processing capability to different part, right? Nanotechnology to make it smaller, as simple as that, right? So it is very easy, right? So once you are having some knowledge about IoT, even you can build everything. So I always tell my student that as an engineer, whatever you can dream, you can design that thing, and even you can implement that thing, right? So as an engineer, whatever you can think, you can make it practically possible, right? Like I told you that now we are working on some signals, brain control devices. With the help of brain signals, we would be able to control equipment of our labs, of our rooms also, or we can move the cursors also, right? It's not about only for fun sake. For example, there are some paralyzed persons, those who wanted to turn on or turn off the devices, wanted to type on the screens, right? By thinking only, you can have all these things, right? So that can be the power of IoT. So this is very wonderful diagram, very beautiful diagram. You can see that current and future prospect. So this data is up to 2020, right? So in 2022, obviously we are double than that, right? So you may see there are three things. One is world population, then another is connected devices, another is connected devices per person, right? So you may see in 2003, the population of the world was 6.3 billion, right? And at that time, the connected devices means it may be smart watches, it may be mobile phones, it may be laptops, anything which is having unique identity over the internet, right? So at that time, the devices were less, right? And per person, it is 0.08. So as the year passed in 2010, the population was 6.8 billion, and the devices were, you may see, from 500 million to 12.5 billion, right? And if we'll see in 2020, 2 years back, it is around 8 billion. And imagine, 50 billion devices. That means started in 2003 from 0.08, in 2020, 6.58 devices per person. That means if I am having, say I'm having one laptop, one computer, one smartwatch, two phones, that means I'm carrying 4, 5, 6 devices with me, and all are connecting through internet, right? So in 2022, this is around 8.6. right? So that is the power. That's why, as even director said that the career is very bright in this field. If you are working with IoT, including cloud and data analytics, enormous opportunities, right? Every day we are getting, calls from industry that we need cloud specialists, we need data analytics specialists, because there is a scarcity of, these people, right? You may complete your BCA, you may complete your graduation, BTech and other things, but if you don't have skill, you are standing nowhere, right? So try to make your skill in any of the technologies, right? So these are interconnection of various things, but even you can granularly you can choose one area and you can excel in that field, like same as doctors do, right? Nowadays we have, a skin specialist, we have a heart specialist, we have a brain specialist, we have a, say ortho. So why specialist? Because specialist means that person knows everything about that portion of your body, right? That doesn't mean that that doctor does not know about anything else, but that particular area is being focused. So similarly, in engineering or in any computer related field, industry people, they ask for specialization, that you should be specialist in particular field. Generic is like ye bhi aata hai, ye bhi aata hai, ye bhi aata hai. That means kuch nahi aata, right? So be specific. So this is the, you may say, the future of the IoT. So as we have seen in the previous slide, that 50 billion devices connected. So when 50 billion machines connected, that means everything is interconnected. You may say OT is virtualized, like we are already doing remote surgeries, robotic surgeries. That means people are sitting in US, doctors sitting in US, they are doing surgery from the Jalandhar, right? So see, these all things are interrelated. Now we are, we are waiting for 5G. Why we are waiting for 5G? What is the relation with IoT, right? If speed would be good, for example, 10 gig would be the speed. If the person is sitting in US, right? Doctor is sitting in the US, that's, say, if he or she is operating and the internet, see, everything is through internet. Without internet, you may not have IoT, right? If the speed is very slow, say around Mbps, so there would be delays. So if there would be delays, that means doctor would not be able to see properly the cameras, because there would be loss of signals, right? So when we are waiting for 5G, that means it has a great impact over the smart cities, the interconnected devices. Why? Because, so try to understand this thing. See, earlier in 4G, the speed was, we say technically it is a latency. Latency is the time taken by, for example, if I need to search something from the Google, I'm typing something. So that response is, that request is being sent to, say, California server. So from California server, it is coming back. So that time is called latency. So earlier with 4G, it was around, you may say 100 millisecond, right? So millisecond, I hope you understand, millisecond is, you can say, 1,000th part of the second. So with 5G, when 5G will come, this speed would be, this latency will be 1 millisecond. So 100 millisecond and 1 millisecond, that means the speed would be very fast. Excuse me, right? So you may see here, everything would be interconnected, right? So that is IoT. So the sky is not the limit. It's only the beginning with IoT. If you, start from after this workshop, you are on right track. So there are number of things. So you can unlock the massive potential of IoT. It will obviously improve the performance when you are having IoT devices that automatically turn on, or you are turning, say, even in automobile, you may say the smart devices, right? So in, say, cars also, there is ADAS system, which is assisting the drivers, that there can be a lane change, say 360-degree cameras, which monitor everything, the proper distance, the tire pressure monitoring, everything, right? So it will reduce cost. new revenue streams. It would create innovative services with great performance, right? So these are some of the applications. You may say not even a single portion is untouched. Say you may talk about online shopping. Even in India, still, I don't think that there is a store of Amazon, right? So Amazon is having a store in US and other Western countries where you need not to have kind of a swapping thing or billing system. Whatever you will pick, you should have that Amazon app, right? So if you are having that app, you just enter into the mall, right? Whatever you will buy, it will automatically be updated into your cart, and even you may leave uh, without paying the bill because it would be automatically deductible from your account, right? Wearable technologies. I hope you all have experienced it. Smart watches. How many steps you have you are having, how much sleep you are having, right? So what is your blood pressure at this time? So they are monitoring you everywhere, right? Even smartphones, we have gyro, we have accelerometer, we have number of sensors in our smartphones. Vehicles, I told you. Home lighting, very good. Nowadays even we have Wi-Fi, Li-Fi enabled even LED devices also, through which you can have internet access, right? You can control your appliances, you can control your automobile from mobile phones. You may track what, if some of your friend is asking you that I wanted to have your car, you may monitor that he or she is going at which location. You may monitor the speed also, right? So everything is possible with IoT, right? So the ultimate goal of IoT is to automate human life, right? One more example, like in coming years, there would be smart refrigerators also, where the refrigerator, for example, will automatically sense, say, what is the quantity of butter left in my refrigerator. Say if it is less than 10 milligram, it will sense the weight of the butter. It will automatically, order to Amazon, and by very next day you will get the butter, right? So that automate human life in coming years, we can imagine, right? So see why we engineers are working on it, so that you perform your work, you do your duty, and leave those or extra things on the technology. They will do it for you, right? So there are number of applications. You may see building, manufacturing, healthcare, environment, right? Infrastructure, energy management, and many more. You name it and you will have it on IoT. So these are again some of the application. I may share this slide with Vishal sir after the presentation. You can have a look, right? So this is one of the example. If you are, say, a UG student or diploma students or engineering student, even you can have your projects also based on IoT, right? So for example, this is honor self-service payment. So even you can see here are the sensors on the parking locations. So they will, even there are devices in your cars also, they will tell you that which location, they will propagate that which location is vacant, right? And at that location you can park your car, right? And even automatically once you will leave, there will not any kind of a person there. The amount will automatically deducted through some payment gateways, right? So again, very good example, right? For example, say in Jalandhar Corporation, even in Fagwada, we are trying to implement it, right? That at every dustbin, smart bins we call it. So there would be IoT devices, and there would be some apps in central location of corporation, and with the vendor, those who are picking those garbages. So once the garbage will be full, only then that person will get a notification that at that particular location, say in Jalandhar, in Model Town, in Adarsh Nagar, in maybe near to Science City or any other location, there would be big dustbins, big smart bins. So otherwise, if there would be no smart things, the vendors will move from one location, check for each and everything, right? It will waste time, it will waste fuel, it will waste money and efforts also. So if we are having smart devices, it will automatically intimate the vendor that say that particular location dustbin is full, you can take that dustbin away, right? So you need not to go to that particular location, which is 20 kilometers away from your location, just to check whether it is full or not, right? So that again is a kind of application. So this is a scenario I was talking about, right? So smart shopping. So there is a scenario that so when entering the door, scanners will identify the tags on her clothes. So when shopping in the market, the goods will introduce themselves. So once you pick it, there would be a message that what are the USPs or the features of that thing, right? So when paying for the goods, the microchip of the credit card will communicate with checkout reader. When moving the goods, the reader will tell staff to put a new one, right? So automatically that now these all things are people are doing manually. That, for example, say you picked some mobile phones. So on that location, there is no mobile phone, but it will intimate the owner also that those 3 inventories are out of stock. Kindly put those mobile phones in the particular location or any groceries as well, right? So that is again one good example of IoT. How many steps I have already discussed that how many steps have you walked? So already our smartwatch capturing all the things. How well do I sleep? So everything, right? Whatever you can think that I wanted to do this thing is possible with the help of IoT, right? So you may say, where are you going? Who you have interacted, the affinity of connections, even all these things like IoT, cloud, AI, they are combinedly, they are doing all these things, right? So this is again what I was telling you, that EEG signals, right? So through EEG headset, the you can see that component or kind of a cap she is wearing. It is EEG sensors basically, right? It's not a normal. You will see. You may imagine it's a kind of a some kind of a fashion. It's not a fashion. It is a kind of a EEG capturing machine, which will capture the EEG, right? So through this EEG, you can do anything. Even you can sense the emotions of a person also. That whether that person is happy, sad, you can control the devices. Even you can play games also, right? So these are some technological challenges, right? So obviously there are some challenges of IoT, which still we need to focus on it. Researchers are working on it, that how we, take these challenges and we are converting these challenges into opportunities, right? So scalability that, say it is usually for a particular application, right? It's not a kind of a scalable thing. I'll tell you scalability once we will be having a session on cloud, right? So scalability is kind that it cannot be scale up or down. So it's a kind of fixed thing till date. So I told you that still it is not a kind of only one standard. It is a different standard combined together to form a IoT application. Interoperability is still a issue, that there are number of, you can say, protocols, number of standards, and sometimes they may have problem with the interconnections, right? So software complexity, power supply, because so when we say if we have to deploy sensors in the field, right? So you may have that capability of those sensors that can survive for years. So you may not go to even, for example, if you wanted to capture the sea status, so that so what is the level of sea? So is there any kind of eruptions in sea? So you cannot change the batteries of all the sensors, right? Obviously, wireless communication itself is having some problems, right? And you cannot use wired services everywhere, right? So there are some challenges which need to be focused. So Vishal sir, can we have some questions, or it would be at the end? Tell me.
Okay.
In between, can we have any questions? 1 or 2?
Okay. Yes, we can take question answers right now. Students, if you have any queries regarding this topic so far that we have covered, so you can ask question by raising your hand so that I can unmute that participant. So if you have any doubt about this, I request the participants, you may raise your hands.
I hope students are, Vishal sir, I hope I'm not boring anyone and all.
Explained it very well and with the beautiful pictures I have seen on the PPTs. And
thank you, sir. Thank you so much.
Anyone? I think we should go ahead, sir.
Right, sir. Right, sir. Thank you.
Yes.
So IoT architecture, I think most of the components I have already explained that. Now we are moving towards the practical things, right? So initially we have seen like sensors and actuators, right? So Vishal sir, I think there is some question from Piyush. Can we unmute him, Piyush Kumar?
Yes, yes. Piyush, you are now unmuted yourself. Yes, Piyush, you can ask question. Piyush? Your voice is not audible.
Piyush, tell me what is your question, Piyush? I think it was, mistakenly he raised his hand. Maybe. Okay, we'll continue, sir. At the end, we can have that session, right?
Sure.
All right. So this is IoT architecture. Like initially, the first point of contact would be sensors and actuators. Vishal sir, can we mute everyone?
Yes, sir. Pardon?
Can we mute everyone?
Yes, sir. Can you repeat?
So can we mute everyone? I think there is some
noise.
Sir.
Yes, sir. I can mute. Okay, okay. Yes.
So as you can see here, like initially we have sensors and actuators, right? So there are two terms I wrote, sensors and actuator. Let me, tell you about this also. I'll relate it with again human body. Like we have, eyes, we have ears, all sensory organs, right? So when, say, if someone is throwing, say, something on me, so what will
Sir, please unmute yourself, sir. Anurag, sir. Yes, sir.
Am I audible now, sir?
Yeah, yes, sir. Audible, sir.
So I was saying that I'm relating these sensors and actuator with our human body. That, for example, my human body is like if someone is throwing something on me, so my eyes will see that something is coming onto me. So my eyes will give signal to my brain that there is something. And similarly, my brain will give signal to my hands to kindly catch that, try to catch that thing, right? So that means I'm sensing through my eyes, my brain is processing it, it is giving signal to my hands to capture it. So that means sensing, processing, and actuating. So similarly in IoT devices, if we are sensing something, for example, say I wanted to have an application like, say sense the moisture of the soil, and if the moisture is very less, turn on the motor, right? So if, for example, if I'm sensing that moisture is very less, it is being processed by the controller and it will give the signal to the motor that kindly turn it on. So actuation means the reverse section which we are sensing, right? So a device that we will study today would be Node MCU, or you may use Raspberry Pi, or you may use Arduino as well. So gateway is a kind of a device through which we are connected to the rest of the world through the cloud, right? So in this architecture, we have a sensors, the device would be a kind of a microcontroller which will take signals, process those signals, transport over to the cloud through some networking devices, right? So this is our, you can say, layered architecture of IoT. So we have a perception layer at the bottom in which we have all the sensors and actuators. Then we have a network layer in which we have routers and gateway through which we are transporting our data to the cloud, right? So this is basically the lower layer, then middle layer. And at application layer, we have cloud or servers through which we capture information. We send it to for data analytics or everything else, right? So it is a physical layer which has sensors or sensing. Network is for smart things, network devices, and application is for user specific, you can say, inputs, right? So I'll give brief introduction of sensors also. As you may see in this diagram, so in a car even there are number of sensors, right? You may see microphone, you may see video cameras, GPS, air conditioning sensor, rear sensor, fuel sensor, tire monitoring sensor, infrared sensor, so gas sensors. So there are number of plethora of sensors available in the automobile devices, especially in cars also. So I hope you all may know. For those who don't know about sensors, it is nothing, as I was telling, it is a kind of a human body, which is like we have a 5 sensor used for sensing various information, say tongue, say ears, nose, eyes, etc., skin. Similarly, sensors, depending upon application, we have moisture sensor, light sensor, gas sensor, fire sensor, temperature sensor. So what is that sensor? It is an electronic component that detects events or changes in the environment and send those information to other electronics for processing, right? So sensing the information, say in a automatic room controller, say for example in our air conditions, so it continuously, that thermostat continuously senses the temperature of the room, right? So if we set at say 23 degrees Celsius, so the temperature is 30 degrees Celsius. So once it would be 23, it will turn on off the compressor. So again, if the temperature is rising, right, that means again it would be turn on. So that is a kind of a basic sensor, right? So as I think I need not to explain about this slide, we have already explained that sensors and actuators. So actuator are kind of a, based on that sensing, what action we need to take place is actuation, right? So students, there are a number of things, right? So you just need to start from some point, right? So this smartphone, earlier we talked about say cars. Now in smartphones, we have number of sensors. So compass, gyroscope, proximity sensor, fingerprint, near field communication, light sensors, back illuminated sensor, even smile capturing, right? Number of sensors are there. So you may see again different types of sensors. So humidity sensor, temperature sensor, velocity sensor, position presence sensor, magnetic field sensor, leaks level sensor, flow level sensors, heart signal sensor, temperature sensors, EEG sensors, ECG sensors. So there are number of sensors available in the market, right? Depending upon for which application we are making our IoT service, right? And again, whatever you can imagine, you can make it. So there are some analog. I hope this is clear. Analog is which is continuous in time. Digital is like kind of a discrete information, like 0 and 1s. Sometimes we need to capture the light. So we use analog sensors like sound, pressure, accelerometer. Sometimes we need to capture 0 or 1, on or off. We prefer a switch. So that is a kind of a digital sensor we have. So again, there are active and passive sensors also. So active sensors, they always need its own energy like battery to work. For example, ultrasonic sensor. So they generate signal. For example, as you can see in this diagram, there are 2 sensors. One is transmitter, another is receiver. So this sensor will send the signal. It will reflect back from some object. This echo would be captured. So that means it is having their own batteries, which will use to produce its own energy. On the other hand, when we say passive sensors, it uses external factor to work, IR, PIR sensors, right? Which usually capture human heat, right? Which is, external, you may say, sensing. So now we are moving toward our practical portion, right? So that was all about, theory. About cloud, I will tell you later on. But before that, let's have a little bit about, Node MCU, some experiment over MCU also, right? So Vishal sir, I hope we are on time, right?
Yes, sir. Yes.
So when we talk about IoT, right, especially IoT hardware component, so microcontroller is a heart, like we have a brain, right? So our human machine is having a brain, we have a sensors, we have actuators. It is like a IoT only, right? So similarly, if you have a brain, it is same as microcontroller, right? Sensors, same as sensory organs. Hands, foots are actuators, right? In brain, we have neural network, which is a storage. Power supply, what we eat, we get energy from food, is a kind of a power supply, right? So microcontroller is nothing but it is a kind of a device which controls everything, which is a heart, or you can say brain of your system, which process everything. What to do with that information is a task of microcontroller. Storage, again, very important. Flash, EEPROM, ROM, other storage devices. Flash, I hope you understand, it's the fastest memory we can have, right? So once we sense that data, we store that data into some memory, right? So nowadays, even we have number of cloud service providers also. I'll tell you about cloud devices later on, right? So power supply, see, one more thing, you can research on everything. So you can have research on controllers, you can have research on power supplies. Power supply means like, say you may have seen like ads like this mobile phone is having a say battery life of 2 days, 3 days, right? So what they are doing, they are continuously researching on those all parameters that will be playing its role. So see, in laptops or in mobile phone, like there is a sleep mode, or if you will not use laptop for say 10 minutes, it will automatically be into the sleep mode. Why? Because they wanted to save the power, because they want that if you're not using it, power should not be consumed from the device, right? So as a student, if you have minor project, you have a major project, or if you don't even have a project, try to bring some devices. I'll tell you what devices, right, today. So don't leave the session in between, because it would be very interesting one. At the end, you will definitely get at least 20, 30, 40%, which you can implement in your projects also, right? And try to make your own project rather than what we see that students usually buy their projects from outside, right? So it is very simple and interesting. Obviously, there would be some things, maybe on one go, it will not work, but once you troubleshoot, you will learn only when you troubleshoot, right? So brain, storage, supply, IO is a kind of input output. For example, if I want to connect a sensor to the controller, there should be some connecting point, right? So IO is input output. Like in computers, we have input output devices. Like, for example, speaker is output device. Say mic is input device, keyboard is input device, right? Mouse again is an input device. So similarly in IoT also, on board we have general purpose input output devices where we can connect input devices and output devices. I'll show you today, right? Connectivity, it can be through Ethernet. Ethernet is like that internet cable we plug into our computer for turning it the internet on. Wi-Fi is again a kind of wireless connectivity. So there is a protocol which is 80 IEEE 802.11. So when we say IEEE, so IEEE is an institute which makes standards, protocols, Institute of Electrical and Electronics Engineer. 802 is LAN, local area network. 0.11 is Wi-Fi standard. Similarly, there are a number of standards. Say 802.3, Ethernet 4, 5, 6, 11. Similarly, Bluetooth 802.15. So there can be a number of connectivity options: Wi-Fi, Bluetooth, Zigbee, Ethernet, serial port. Today we'll use Wi-Fi and a serial port, right? Students, you may ask question later on, right? Yes, coming to this thing. So this is a small device. I'll show you this device to you as well. Let me hold this device for a while. So can you see this one? So this device, right?
Yes.
So this is Node MCU, right? I'll tell you what is the use. This is, we call say IoT board. right? Why we call it IoT board, I'll tell you, right? So it looks like, a 10 rupees dairy milk, right? So it is very small. It costs around, there are again two things. One is Indian made, another is Chinese made. So it costs around 500-600 or maybe cheaper also. Online there may be a discount 300-400 also. But this device is IoT device, and it is, you can say, you can do everything. Even you can control your all devices through mobile phones. That I wanted to turn on my AC, I wanted to turn on my tube. So sometimes when we feel relaxed, we don't want to get up from our beds, right? So what we will do, we can control our TV, fridge, AC, everything through mobile phone, right? Through with the help of IoT. So within 600 to 700, you can make this project also, right? So this is nothing, but it is a microcontroller. You may see it is an open source. Open source means anybody can contribute, right? It has inbuilt ESP8266. So this is a beauty. So you must have heard about Arduino also. Arduino is almost same as Node MCU, with a difference that Node MCU has inbuilt Wi-Fi module, right? कि इसके अंदर जो है इनबिल्ट वाईफाई मॉड्यूल है, आपको एक सेपरेट वाईफाई मॉड्यूल लगाने की जरूरत नहीं है, right? So that is the main difference. So it has 10 GPIO, as we have already, this is general purpose input output, right? 10 ports हैं, lines हैं input output के लिए. एक analog है, बाकी digital है, right? USB connected है. This is a kind of a USB जो आपकी normal cable होते हैं mobile phones वाली. I'll show you today, right? So even you can connect with those cables also. This cable, is it visible? Is it visible, that cable? This one, that normal mobile phone cable. I hope it is visible.
Yes, sir. It's visible, sir.
So you can program it through that cable only, right? I hope you must have that cable also, right? So that is the beauty of this device, that it can control everything, right? So again, there are a number of microcontroller you may use depending on different applications, right? Even you can check, I'll share the link this. So this is the comparison of families. So once you will click over it, you will see, so there are, say, Raspberry Pi, there's an Arduino Nano, there's Node MCU. You may compare that, what is the difference? These all devices are IoT enabled, right? You can choose any of them, but depending upon the, again, cost and the application. Are you getting my screen? No. Let me share it again.
Yes.
Just a minute. I hope now you are getting it. Yes. So you may see, so they have compared each and everything here. This. So there are a number of microcontroller like Node MCU, different versions, so Arduino Nano and this. So you may have like comparison. What is the power supply? What is the current consumption? What are input output ports and everything, right? So like there are only one analog ports in, say, Node. There are 15 in different one, right? And digital pins are different and cost is different. So you may compare, right? But today we'll use Node MCU, right? Because it's the cheapest one and it is very handy to use. Should I show you something? Have you heard about Tinkercad also? Let me share my screen, just a minute. I hope you all can see my screen.
Yes, sir. It is visible, sir.
So this is a kind of a one simulator that if you don't want to bring that hardware, right? You don't want to spend that amount. So this is one website, Tinkercad, you can note down, right? Whatever you wanted to make, you can first simulate it, that whether it is working or not, right? So you may click on, say, there are different things. Let me open circuits. Just a minute. Just a minute. Yeah, this one. So see, so this is kind of a, let me open one new one.
Sir, we need to register in this Tinkercad.
You need not to register. It's a kind of a, single sign-in. You can sign in through Google Mail also, through Facebook also, right? So it's just I'm showing something that, for example, if you wanted to have Arduino board, if you don't want to purchase, you can have it on this online board, right? Say I wanted to code it, so I'll click on code. So there is an option that you may code like blocks or text, right? So if I wanted to write code, so there is an option like for student, those who are beginner, they may use blocks only. I hope you may see this one, this right one, forever set built-in LED
Yes,
and on off. So say what we will do. So say I'll tell you about this code only. So start is like on start, what that processor will do nothing. So forever means it is a loop that it has a built-in LED. I think this L, you can see this L.
yes, sir.
So what it will do, so set built-in LED to high. What it will make this LED, this bulb on and wait for, let's say, I can change it for 10 seconds, right? Then set built-in LED to low for, say, 10 seconds. So what it will do, so what I have programmed, this is for kids, right? Those who are beginner to, say, coding. So forever, हर time क्या करना है? LED को on करना है कितनी देर के लिए? वेट कितना करना है? 10 सेकंड. फिर LED को लो कर देना कितने टाइम के लिए? 10 सेकंड के लिए. अब मैं जो छोटा सा कोड चलाना चाहता हूँ, ठीक है? तो मैं क्या करूंगा? Start simulation, right? Now check this LED. It is glowing. Is it?
Yes, sir. Sir,
Can
is
you
it a
see?
real-time simulation?
This is real-time simulation. Means whatever you will do. For example, now I don't know how to program it, right? So I can even download that code also. This is a beauty, right? So it is on for 10 seconds. Say I want it is for say 2 seconds, right? And again it is for 2 seconds. 2 seconds के लिए on हो, 2 seconds के लिए off हो. अब देखना इसकी speed बढ़ जाएगी. See, 2 seconds on, 2 seconds off, 2 seconds on, 2 seconds off. I hope you are getting it.
Yes, sir. We are getting.
So even if you wanted to download, क्या अब मैंने blocks के लिए मैं code download करना चाहता हूँ, I can download the code also. Good one. So even
Is it a free of cost, sir?
Yes, of course. If I wanted to add say breadboard, so breadboard, if someone knows, breadboard is like a kind of a device which looks like a bread, right? But not at all a bread, but you can use it, right? How you can use it? Say for example, I want that I should interconnect some LED with it. Just a minute. Say this is say RGB LED. RGB LED means it will connect. Say this is red, this is common, this is blue, this is green. So common means Cathode means common cathode. So common cathode, we know it is connected with ground. So it would be connected with ground, right? Say this one, right? Similarly, we can have it with digital ones are with some input pins. This, say 1, we can connect it 1. Then say blue with something, say 3. Then next one with this, right? So this is a normal interconnection, and I want that I should code this. So what we'll do again, we'll go to code. So you need to add some more codes that now there is no built-in. We want that there should be some external device. So what I'll do, I can add this one, right? So I want that set pin number at which pin I have connected, say 5, right? Set pin number, just a minute. Set pin number 5 to 1, right? And again, I need to copy this. So duplicate and I'll paste it here. Wait for 2 seconds and then again make it say 0. So I wanted to simulate it. कि मैंने क्या किया, जो 5 नंबर पिन के साथ कनेक्टेड है, राइट? 5 नंबर पिन के साथ कोई या RGB में से कोई एक कनेक्टेड होगा, वो 1-2 सेकंड के लिए ग्लो करे, फिर बंद हो जाए. So what I'll do, I'll simulate it. Just a minute. So this is plugged in. I'll show you practically also. I'm showing it. See, so this is connected. Now it is showing green after say 2 seconds. Can you see this?
Yes, sir. It is visible, sir. It's working.
Yes. So that means if you don't want to purchase anything, even you can code. And if you don't know even coding, what you can do, you can join blocks like kids. And at the back end, you can download the code. I'll stop simulating code. So I want to have the code. I wanted to burn this code. What I'll do, I'll click here that text, right? This is a code automatically behind that blocks. Interesting, right?
Yes, sir.
So this is one thing, but I'll show you practically today, right? So coming back to the presentation, where it is, just a minute. I hope you all are getting it.
Yes, sir.
So quickly to the current slide. These are all, comparisons. Now check this very carefully. Like, say, this is A0 is kind of an analog pin, then ground pin, which we utilize. Reset pin, 3 volt, ground. These are digital input outputs. We can make either it input or output. TX, RX is kind of a transmitter and receiver to connect some output device, which is serial in nature, right? So these are the, theoretical ones. This is that 8266 inbuilt module. So it looks like this. So it has, Node MCU has inbuilt Wi-Fi module, which has, see, this zigzag is an antenna, Wi-Fi antenna. You may see 802.11 BGN. This is Wi-Fi standard, right? So I'll not explain. Yes. So this is today's task, which is very important. If you see this, you would be able to make small projects and even gradually the bigger one also, right? So demonstration using Node MCU. So what we will cover, first of all, installation of Arduino IDE, because it is common for Arduino and Node MCU. Then we'll connect Node MCU with our system, install some libraries. I'll tell you then some programs. Then we'll put data on cloud at an end, right? Starting with the installation, right? So you all can note down, even you can do it yourself at home. I think the session is being recorded. Even you can get the recording link also, right? So through this website, once you will click on this website, it will land it to the Arduino software, Arduino IDE. IDE is what? Integrated Development Environment, right? So let me open this. Okay, let me first complete this, then I'll open Arduino IDE because again, it would be difficult to flip on these. So once you will install it, you will have, okay, let me open it because then only you will. Just a minute. So it will take a couple of minutes. In the meantime, we can have that. So it will take a couple of minutes. In the meantime, what we can have that PPT only, right? Because on another laptop, I'm doing it, right? It is opened. I hope you are getting my screen.
Yes, sir.
So you may see once you download it. So just wait. So it will look like this. You will get this shortcut on your desktop, right? So once you will open it, so it would be like this. You will get this one, right? So how you will get this one? So you'll click File. Once you will do it, say New. So you can get this one, right? So before starting with the Arduino board, before interconnection with the Arduino board, you need to install. You need to add some path over it. So that path would be added here. So go to File, then Preferences. So you may see here additional board manager URL. So this is the link which you can get. It is available over the net. So you can get this link through internet only, through Google only, right? So what is that link? That you need to add that Node MCU board into your Arduino IDE. कि ये जो board हमने connect करना है, कौन सा board? This one. I hope you can see. Vishal sir.
Yeah, yes, sir. We can see, sir. We can see. Yes.
So I have connected this board with this wire, right? So for that you need to connect board and you need to add the path. Then only you will get the board, right? So once you add the board, then you can check, and the board is connected with through the cable, right? So you can check here. It will show port COM, like my board is connected through COM 6. If I'll disconnect, it will not show here any COM port, right? And you need to select here board. Even students, if you are interested, you can note down the steps or you can check the recording as well, right? So like, what is my board? It is Node MCU 1.0. So I need to check this one, right? So that is my initial task, right? Right? So by default, there would be two things. There would be two functions. One is setup, void setup, another is loop. Void setup is like, here what we will write some pins. Like जैसे मैंने अभी क्या किया था, मैंने पिन नंबर 5 को LED से कनेक्ट किया, उसको आउटपुट पिन बनाया. आउटपुट मीन्स उसको सिग्नल दिया ताकि लाइट ग्लो करे एंड लाइट बंद हो जाए 2 सेकंड बाद. सो वो सेटअप सारी जो मैंने करनी है वो यहाँ पे मैं करूंगा. मैंने सीरियल पोर्ट मतलब से जो मेरा लैपटॉप है या जो मेरी Arduino ID है, it has say serial monitor here, so it is connected through this Arduino ID. अगर मैंने उसको यहाँ पे स्टार्ट करना है तो मुझे स्पीड भी मैच करनी पड़ेगी. सो सेटअप इज काइंड ऑफ ए कौन सी कॉन्फ़िगरेशन आपने करनी है, जैसे सिस्टम ऑन होगा सबसे पहले वो ये सेटअप करेगा, राइट. लूप मीन्स जो आपने रिपीट करना है. I'll show you some of the example, right? So let me open one example. Say open. I have made something for you. So initially, say blank one, or say hello world, right? This is a kind of just a minute. I hope you are getting the screen.
Yes, sir.
So you may see, like, this is a kind of a normal text I wrote here. So void setup means serial.begin means we have to open a serial port, right? And transfer it. Transfer means किस speed पे data भेजना है, जिस speed पे वो receive कर सके. As simple as कि मैं किस speed से बोलूँ, अगर मैं क्लास में पढ़ा रहा हूँ, लिखवा रहा हूँ, dictate करा रहा हूँ, मैं इतनी speed से बोल रहा हूँ, आप लिख ही नहीं पा रहे. So obviously students will say, sir, please slow down your speed, right? So this is the speed at which transmitter and receiver can communicate, a matched speed, right? 96 bps, bits per second. So here we wrote this. Loop means आप क्या करो, print करो ln मतलब next line में हर बार ये वाली line, और हर print के बाद 1000 मिलीसेकंड मतलब एक सेकंड की डिले दो, right? I'm uploading this. मेरा जो बोर्ड है वो कनेक्टेड है. You may see this, this one, right? मेरा बोर्ड कनेक्टेड है Node MCU. वायर्स को छोड़ दो, अभी वायर का पर्पस डिफरेंट है. Let me turn off this light. Now check. So मेरी वायर के साथ मेरा Node MCU कनेक्टेड है. अब वो Node MCU क्या कर रहा है, खाली Node MCU कनेक्ट है, बाकी ब्रेडबोर्ड की जरूरत नहीं है, वो मैंने किसी और काम के लिए लगाया, राइट? So what it will do, let me share this one, right? I hope you are able to see the Node MCU. I think it's blur, maybe, right? Now, Vishal sir?
Yes, sir.
Are you able to see Node MCU?
Yes, sir.
So see Node MCU is connected with the wire. So what I'm doing, as we have seen in the simulator, I am putting this, I'm uploading this code into Node MCU. So once I'll click upload, see all this code would be uploaded. You can see here at the bottom, it is compiling sketch, right? Okay, मैंने इस speed पे इस loop को compile कर दिया. Now it will compile first and then it'll upload onto the Node MCU. It will take a couple of minutes. This is my serial monitor. Just a minute. It is showing some error. So let me again select that board. Just a minute. Let me reconnect that with some different port. Let me restart this. Just a minute. Let me upload one more port. Just a minute.
Such type of problem, sir, it happens, I think, in Arduino too. We have to change that port.
See, sir, when we are doing something practically, it is always like a kind of a troubleshooting part. So that will make you learn, right? Otherwise, if it always starts in a simple mode, then there should not be any kind of a learning. So we learn only when we get problem.
Yes.
So let me restart my computer and really check it. Just a minute.
So what is the operating voltage of that Node MCU, sir?
Sir, we usually, it is having 5 volt also, it is having 3.3 volt also, but we usually take it 3.31. So let me connect with this PC. I think there is some problem in the PC only. Just a minute, sir. So let me restart my other computer. In the meantime, what we can do, we can talk about cloud more, right? Just a minute. I'll tell you here and then we will do some practical. I hope you are getting my screen. No?
No, sir.
Just a minute. So I hope you are getting my screen.
Yes, sir. It is visible, sir.
Okay. So as we have seen that, so what is the first step? So once you open the Arduino, you have to set the path of that board, right? So which is under that file, additional board manager URLs, right? Then we need to select our board through the board manager, right? That is, you go to tools in that and select board manager, and we need to select our own board, that is Arduino Uno. And then the important one. So once you install that board, then you need to have ESP8266, right? Search ESP, then 8266, then you will get this one and then install this. So why we are installing it? Because we need to have that Wi-Fi along with that. So we are installing that Wi-Fi module, which is inbuilt into the ESP module. Right? And again, you can check for that Node MCU is being selected or not. So you can check this one, right? So which was coming on our board. I hope you must have seen when we see board Node MCU, CPU frequency 80 megahertz, then flash size, upload speed, port can be depending on which port you are using, right? Just a minute. So this is the program. I have already explained the structure. That void setup is for the instruction, which is, we can have for the first time when we are turning on the Node MCU. So it will run once only, this instruction, serial.begin. So what instruction is saying that please start a serial port, which is this one, at a speed of 9600 bits per second. And this function while loop means it would be continuous. It will continuously generate serial.println means next line print this, whatever we will write, it would be printed on the serial port. Delay means after every text or character, please put 1 second delay, 1000 millisecond or 1 second, right? So even then you can check, once you will click here, you will get, say this was hello world, you will get hello world, hello world, hello world printed on your, you can say serial port, right? Similarly, we can have that built-in LED program also, right? Built-in LED program is like, so it has MCU, Node MCU like this one, it has inbuilt, you can say LED at pin number this near to 13. So once we can have again, which we shown in the Tinkercad also, that on for some time, off for some time. For 10 seconds it would be on, for next 10 it would be off, right? So that can be the another one. Just a minute. So let me again check. I have restarted my computer. Again, having some error of COM. Let me select the different one. No issues. In the meantime, we can have one more thing. Just a minute. I suppose now it is working. So let me connect to Zoom. First, let me run this. Yes, it's working. Vishal sir, can you let me in from the another computer as well?
Yes, sir.
Just a minute. Let me request.
Please let me know the name.
Yes, sir. Just I'm joining through the computer. Right?
Okay, sir.
Just give me a minute. Sometimes it is difficult to present virtually because physically you may.
It happens in online sessions. Sir.
Yes, physically you may demonstrate everything, but virtually you need to show everything through cameras only.
Yes. So can we say that Node MCU is a microcontroller?
Yes, sir. Yes, sir. Definitely.
Okay.
So see the Arduino. It's a same family of Arduino with the interconnection of that Wi-Fi module only. So that's why we say it is a IoT board, because it can directly sense your data or sense your environment and put it over the net, right? With in Arduino we need to add separate 8266 board.
Oh yes, that Wi-Fi module, huh?
Haan ji, sir.
Yes.
Just a minute. So that Hiten Sharma, same name, I'm connecting through that.
Okay, sir.
Yes, sir, I'm in.
Okay.
I hope I am having a rights to share the screen as well.
Yes, sir.
Let me stop
Yes, sir,
share screen from this side.
Okay.
So let me share my screen. I hope you are getting this. Before
Yes,
that, I'll do one simple one. Say hello program, right? I hope it is visible now, the same program.
yes, sir.
So now my board is Node MCU is connected with, check this, tools. Now through COM port, my Node MCU is connected with my computer. So it is plug and play. So I need to connect that cable with my USB over the Node MCU, and it would be automatically comes here, right? And the same parameter like Node MCU and everything. So I wrote that code and upload. So this is the practical one. So earlier we do it in the simulator, right? So if you don't have Node MCU, you can do it on simulator as well. So it is compiling the sketch again. You may see here, it is compiling the sketch. Now it is uploading. You may see writing means it is writing onto the Node MCU. So with percentage 38%, 46%, 53%, 61, and so on. Right now, uploading would be done. So that means this code has been uploaded over the Node MCU, right? So once we will click on serial monitor, you will check it's a timestamp, or you may remove this. Just a minute. I think it is not visible to you. I hope it is visible, the screen.
Yes, sir. Visible, sir.
So with time, you can see 438. This time it is printing, right? And here we have like a baud rate, that bits per second, which we said serial bit rate. We may change also, right? So this is number one. And just a minute. Now what I'm showing you, LDR, right? So first we will understand about LDR, because now I'm putting that LDR data onto the cloud. First, I'll put that LDR data onto the serial port. Then in next experiment, I'll put that sensor data, that light data onto the cloud. Why? Because that is make our IoT device that we are sensing data of say street lights, and we are putting that data onto the cloud. So may other one from all over the world may see it, right? So before that, let me stop sharing from here and talk about LDR first. Right? So this is LDR, right? LDR is light dependent resistance. So as you may see, this is a kind of a device which is, this zigzag is a kind of a photoresistive material, photosensitive material. Photosensitive का मतलब क्या है? जब इसके ऊपर लाइट पड़ेगी इसकी रेजिस्टेंस चेंज होगी, जब इसके ऊपर लाइट नहीं पड़ेगी रेजिस्टेंस चेंज होगी, राइट। सो एज लाइट फॉल्स ऑन इट, लाइट फोटॉन्स आर अब्सॉर्ब्ड बाय द सेमीकंडक्टर एंड ट्रांसफर टू इलेक्ट्रॉन। जितनी इसके ऊपर लाइट पड़ती रहेगी इसका करंट जो है वो और इंक्रीज होता रहेगा, राइट। जितनी कम पड़ती रहेगी उतना इसका करंट कम होता रहेगा, एज सिंपल एज दैट। आप इतना एज्यूम करो कि जब लाइट पड़ेगी तो इसकी रेजिस्टेंस चेंज होगी, जब लाइट नहीं पड़ेगी इसकी रेजिस्टेंस फिर से चेंज होगी, राइट। अब हम इसको यूज करने जा रहे हैं कुछ इस तरह के सर्किट से, राइट। अब ये सर्किट देखो, इट इज वेरी इंटरेस्टिंग, ध्यान से समझो। जिनको नहीं भी पता कुछ IoT का, इंटरनेट का, इलेक्ट्रॉनिक्स का, वो भी समझ सकते हैं कि यहाँ पे एक सप्लाई है। जस्ट अ मिनट, दिस इज अ 3.3 वोल्ट सप्लाई, दिस इज अवर LDR, हियर वी हैव अ रेजिस्टेंस, हियर वी हैव अ ग्राउंड। अब हमने क्या किया, एक सर्किट बनाया। एक सर्किट का जैसे हम बल्ब जगाते हैं, तो बल्ब कैसे जगाते हैं, अगर मैंने बैटरी के साथ बल्ब जगाना, एक टर्मिनल पॉजिटिव को दे दिया, एक नेगेटिव को दे दिया, राइट। सेम चीज, पॉजिटिव टर्मिनल एंड अनदर वन इज कनेक्टेड टू ग्राउंड। रेजिस्टेंस इसलिए कनेक्ट करी गई ताकि LDR का पाथ डिफाइन हो सके कि जब जहाँ पे लाइट पड़ेगी तब क्या होगा। बेसिकली अब यहाँ से करंट फ्लो हो रहा है, जब इसके पास लाइट पड़ रही है, राइट, इसका मतलब करंट ज्यादा फ्लो होगा, राइट। तो उसकी इंटरकनेक्टिविटी कर दी A0 से। A0 क्या है, एनालॉग पिन है नोड MCU की, कि जब लाइट पड़ेगी इसकी रेजिस्टेंस जो है वो इंक्रीज हो रही है, सॉरी इसकी रेजिस्टेंस डिक्रीज हो रही है, करंट फ्लो ज्यादा हो रहा है, राइट। उसके कारण इसकी आउटपुट चेंज हो रही है, जब इस पर लाइट नहीं पड़ रही तो कोई और आउटपुट आ रही है। तो ये वाली चीज अभी मैं डिमॉन्स्ट्रेट करूंगा। अब देखो ये चीज हम प्रैक्टिकली करके देखेंगे। और दिस इज LDR, इस तरह से सर्किट बना हुआ है, राइट। ग्राउंड मतलब ग्राउंड टर्मिनल, ये सप्लाई है, ये LDR लगा है, ये रेजिस्टेंस लगी है। ये वाला कनेक्शन कहाँ जा रहा है, A0 को, इनपुट पिन को, ऑलराइट। अगर मैं एक और सिंपल मेथड से आपको समझाऊं, जस्ट अ मिनट, यहीं पे आपको कराता हूं। अब यहाँ पे देखिए, नाउ दिस सर्किट, राइट। अब यहाँ पे देखो वही सर्किट बना दिया। अब दो वायर्स निकाली, ये ग्राउंड वाली थी, ग्राउंड को दे दी, यहाँ से 3.3 वोल्ट की थी, वो सप्लाई को दे दी। अब ये जो LDR की आउटपुट है वो A0 पिन पे कनेक्ट करी, ठीक है। सिर्फ इतना सा सर्किट है। अब करेंगे क्या, हम देखते हैं, राइट। अब ये वाला प्रोग्राम चेक करो। अब ये प्रोग्राम है क्या, देखो, वॉइड सेटअप वही क्या कर रहा है कि मैंने सीरियल पोर्ट को ऑन करना है, कितनी स्पीड पे, 96 बॉड रेट बिट्स पर सेकंड। अब यहाँ पे चेंजेस क्या होंगे, मैंने एक इंटीजर लिया, कोई सेंसर वैल्यू। मैं क्या कर रहा हूँ, जो वैल्यू है सेंसर की, कहाँ से मैंने उठानी थी, कौन सी पिन से, A0 से। अब ये कमांड है एनालॉग रीड के, ये पिन है एनालॉग इनपुट के लिए, इसको रीड किया, किस वेरिएबल में डाला, इंटीजर में सेंसर वैल्यू। अब ये एक मेरा वेरिएबल है जिसका नाम है सेंसर वैल्यू, उसमें कहाँ से इनपुट आ रही है, A0 से, राइट। जो भी रीड करेगा ये वैल्यू वहां से, वो सारा का सारा डाटा कहाँ चला गया, सेंसर वैल्यू पे, ठीक है। मैं इसको भी प्रिंट करा सकता हूँ सीरियल पोर्ट पे, पर मैं क्या कर रहा हूँ, मैं इस वैल्यू को वोल्टेज में कन्वर्ट कर रहा हूँ। तो मैंने क्या किया, अब जो मेरा LDR है उसकी आउटपुट कहाँ तक जाती है, 0 to 1023, उसकी रेंज कितनी है एनालॉग की, 0 to 1023। अब मैं कन्वर्ट करना चाहता हूँ उसको 5 वोल्ट में, तो मैंने जो वैल्यू आई मल्टीप्लाई बाय 5 ओवर 1023, ताकि मैं इस सारी वैल्यू को 5 वोल्ट में कन्वर्ट कर सकूं। आई होप इट इज क्लियर। तो जो रॉ वैल्यू आ रही है मेरी, उसकी रेंज है 1023, तो मैंने 1023 5 ओवर 1023 इंटू दिस, तो मैं इस पूरी रेंज को 5 वोल्ट में कन्वर्ट कर रहा हूं। इज इट क्लियर? I hope it is clear, simple है।
Yes.
And then I am displaying that voltage over the serial port. मैं इतना काम कर रहा हूँ, मैं इसको एक्चुअल में अपलोड करूंगा किसमें। अब मैंने ये देखो, आई होप इट इज विजिबल, मैंने वो LDR लगाया हुआ है, वो रेजिस्टेंस लगाई हुई है और A0 पे कनेक्टिविटी की है, इफ इट इज विजिबल, जस्ट नीड टू टर्न ऑन दिस, ठीक है। वो सारे कनेक्शन मैंने लगाए हुए हैं। किसी दिन फिजिकली वहां पे आके भी आपको ये डिमॉन्स्ट्रेशन या और कोई प्रोजेक्ट की हो जाएगी, सेम नोड एमसीयू कनेक्शन कैसे करें हैं, इस तरह से। वो क्या है, ये इस तरह का सर्किट मैंने ब्रेड बोर्ड पे बना लिया, राइट। अब मैं प्रैक्टिकली इसको शेयर करने जाऊंगा, मैं इसको अपलोड करूंगा। इज इट विजिबल दिस कोड? मैंने अब आर्डिनो आईडी ओपन करा है, वो सेम चीज अब मैं अपलोड करने जा रहा हूँ यहाँ पे। आई नीड वन फोन ऑल्सो, क्योंकि मैं आपको लाइट ऑन करके ना लाइव दिखाऊंगा कि उस पर क्या इम्पैक्ट पड़ेगा। Just a minute. So it is uploading 61%. Now अब ये पूरा कोड कहाँ पे अपलोड हो रहा है? On Node MCU. मेरे को विजिबल सीरियल पोर्ट, ये इनबिल्ट सीरियल पोर्ट है जहाँ पे जो सारी वैल्यू है डिस्प्ले हो जाएंगी। ठीक है, इसके बाद हमारा नेक्स्ट टास्क है जो लास्ट वाला, कि हमने सारा डाटा कहाँ पे डालना है? क्लाउड पे, राइट। नाउ डन अपलोडिंग। अब मैं सीरियल पोर्ट ओपन करूंगा, उससे पहले मुझे स्टॉप करना पड़ेगा क्योंकि वो विजिबल नहीं होगा आपको एज इट इज। I hope you are getting that COM port now. Yes.
Yes sir.
अब देखो वो डाटा आ रहा है इन द रेंज ऑफ 5, क्योंकि मैंने उस एनालॉग सिग्नल को 5 के साथ मल्टीप्लाई किया ओवर 1023। अब मैं एलडीआर के ऊपर हाथ रख रहा हूँ, क्यों? क्योंकि मैं डार्क की सिचुएशन दे रहा हूँ कि स्ट्रीट लाइट कब ऑन होगी, जब डार्क होगा। तो मैंने उस फोटो सेंसिटिव मटेरियल को हाथ रखा। अब देखो वोल्टेज कम होगी। मैंने अब क्या किया, उस एलडीआर के ऊपर हाथ रख दिया सिंपली। अब देखो जो 2 आ रही थी, 1 आ रही थी, अब कितनी रहेगी? 0.86 एंड सो ऑन। अब मैं इल्यूमिनेट करूंगा इसको। मैंने लाइट फोन की जगह, अब देखो कितना 5 हो गई वो। आर यू गेटिंग दिस?
Yes sir.
अब देखो 5 वोल्ट उसके अकॉर्डिंगली एलडीआर के ऊपर अब लाइट इल्यूमिनेट हो रही है। लाइट इल्यूमिनेट हो रही है मतलब करंट बढ़ रहा है। करंट बढ़ रहा है मतलब V इज इक्वल टू आई आर, राइट। सो वोल्टेज भी बढ़ गई। अगर मैं लाइट पीछे कर रहा हूँ, अब देखो प्रैक्टिकली ये लाइट पीछे कर दी मैंने, फिर वोल्टेज कम हो गई। अब और डार्क कर दिया मैंने, वोल्टेज और कम हो गई। गेटिंग दिस?
Yes sir.
सो ये एक मेरा लाइव प्रोजेक्ट बन गया। अब इसकी हेल्प से मैं कुछ भी बना सकता हूँ कि जैसे ही वोल्टेज लाइट उसके ऊपर पड़ेगी, स्ट्रीट लाइट्स, कि जैसे लाइट कम होगी अपने आप स्ट्रीट लाइट्स ऑन हो जाए, राइट। अगर ऑन हो गई, लाइट ज्यादा हो गई, या स्ट्रीट लाइट बंद हो जाए। सो दिस इज वन एक्सपेरिमेंट, राइट। सो मैं स्टॉप शेयर करके आगे चलता हूँ। सर हाउ मच टाइम वी हैव? विशाल सर यू आर नॉट ऑडिबल।
Sir, 15 minutes sir, you can
ठीक है,
take.
ठीक है, मैं क्विकली ना बता देता हूँ, फिर किसी दिन
Yes,
और
sir,
प्रैक्टिकल
sure,
सेशन कर लेंगे।
Sir, tell them कि sir how to put
हाँ,
that.
वही
on
बता
the-
रहा हूँ सर।
Yes sir.
अब हमने क्या करा अभी तक? हमने आर्डिनो आईडी देख लिया, कनेक्शन देख लिए, एलडीआर का डाटा सीरियल पोर्ट पे। अब जो मेन बात आती है क्लाउड। अब सबसे पहले क्लाउड की जरूरत क्या है? क्लाउड इज नथिंग बट, अब हम सब चीज बात करते हैं क्लाउड पे डाल रहे हैं, क्यों? क्योंकि हाई अवेलेबिलिटी, नंबर 1। हाई अवेलेबिलिटी मतलब डाटा आपका लॉस नहीं होगा। अगर आप इंस्टाग्राम यूज कर रहे हो, आपका डाटा कहीं कोई फोटोग्राफ वीडियो फोन में स्टोर नहीं है। कहाँ पे स्टोर है? क्लाउड में हो सकता है, कैलिफोर्निया में। लॉग इन करो, यूजर नेम पासवर्ड डाल लो, जिस मर्जी कंप्यूटर लैपटॉप फोन से आप डाटा उठा लो। क्यों? क्योंकि वहां एक सेंट्रली स्टोर्ड है। हाई अवेलेबिलिटी मतलब पैरेलली वो 3 जगह पे स्टोर है, हो सकता है यूएस, यूके, कनाडा। क्यों? कि अगर कोई प्रॉब्लम आ भी गई एक साथ 3 जगह पे तो नहीं आएगी, राइट। हाई अवेलेबिलिटी डाटा जो आपका प्रिजर्व रहेगा। कॉस्ट विच इज वेरी इंपॉर्टेंट। कॉस्ट मतलब अब पहले क्या होता था, हमें हर चीज खरीदनी पड़ती थी। अगर मैंने वेबसाइट लॉन्च करनी है, सबसे पहले सर्वर खरीदो, फिर स्पेस, फिर सर्विस, सब कुछ खरीदना पड़ता था। आजकल सब कुछ रेंट पे है। वी कॉल इट इंफ्रास्ट्रक्चर एज ए सर्विस, सॉफ्टवेयर एज ए सर्विस। आप देखो ऑनलाइन सारी चीजें आप प्ले कर, गेमिंग कर सकते हो, कुछ भी कर सकते हो, ठीक है। तो क्लाउड 3 बड़े प्लेयर है मार्केट में, अमेजन, माइक्रोसॉफ्ट एंड गूगल। AWS जिसको हम बोलते हैं अमेजन वेब सर्विसेज, माइक्रोसॉफ्ट एज्यूर एंड गूगल क्लाउड। जैसे जीमेल, आप सारा क्लाउड पे है, आपका डाटा सेव हो रहा है, राइट। मैंने बता ही दिया कि अगर आपने वो करना था तो अच्छा, एक और एडवांटेज सबसे बड़ी, पहले क्या होता था कि एक वेबसाइट जो एक सर्वर हैंडल करता था से 100 रिक्वेस्ट एट ए टाइम, 200 रिक्वेस्ट, जो हम स्केलेबिलिटी की पहले बात कर रहे थे। अब अमेजन को पता है दिवाली के दिनों में मेरे पास लाखों कस्टमर एक टाइम पे आएंगे, जो हाई अवेलेबिलिटी है, जो स्केलेबिलिटी है, क्योंकि लिमिट सर्वर की नहीं है। अमेजन ने पूरी दुनिया में कब्जा कर रखा है, डाटा सेंटर लगाए हुए हैं। आज 1000 रिक्वेस्ट है, अमेजन को पता है दिवाली के 3 दिनों में 1 लाख रिक्वेस्ट आएगी। अब वो तो क्रैश कर जाए सर्वर, तो पीछे से क्या है, बैक एंड में स्केलेबल किया हुआ है। स्केलेबल मतलब जितने यूजर उसके अकॉर्डिंगली सीपीयूज बढ़ते जाएं, जितने कम है उतने कितने कम होते जाएं, स्केलेबिलिटी, राइट, विच इज द बिगेस्ट एडवांटेज ऑफ क्लाउड। डिसएडवांटेज क्या है, इंटरनेट, अच्छी स्पीड है, डाटा सारा उनके पास है, कुछ भी हो सकता है, राइट। तो आई एम स्किपिंग दिस क्योंकि ये बहुत एक अलग से टॉपिक है, राइट, बिकॉज मैं डायरेक्टली पॉइंट पे आऊंगा। ये कुछ प्लेयर्स हैं मार्केट में, अलीबाबा भी है, AWS है, राइट। थिंगस्पीक इज अ काइंड ऑफ अ फ्री क्लाउड सर्विस। अब थिंगस्पीक में क्या करना है, जो हमने एलडीआर का डाटा देखा, अब मैं यहाँ बैठा हूँ जलंधर में, मैं चाहता हूँ कि मैं अपनी लोकेशन का कुछ भी, एक एलडीआर एग्जांपल है, अब मॉइस्चर सेंसर, टेम्परेचर, ईसीजी, ईईजी कुछ भी डाल सकते हो। आपने डालना है क्लाउड पे, तो आप कैसे डालोगे? तो थिंगस्पीक इज हैविंग, इट प्रोवाइड्स यू 3 और 4 फ्री चैनल्स। चैनल का मतलब जहाँ पे आप डाटा कैप्चर करके क्लाउड पे डाल सकते हो, राइट। तो इट्स ओपन IoT प्लेटफॉर्म, मैटलैब एनालिटिक्स के लिए यूज है। वो डाटा आपके पास आ गया, उसका आप डाटा एनालिटिक्स भी कर सकते हो कि क्या उसको करना है, डाटा को कैसे करना है। thingspeak.com जाओ, फ्री है सब कुछ जो मैं बता रहा हूँ, ये सारी फ्री सर्विसेज हैं। साइन अप करो, अपना ईमेल आईडी, अपना पासवर्ड डालो, ठीक है। इस तरह से आपको एक स्क्रीन मिलेगी, मैं करके दिखाता हूँ आपको, राइट। नया चैनल बनाओ कि अब मैंने एलडीआर का डाटा डालना, तो मैंने क्या किया, न्यू चैनल क्रिएट कर दिया, नाम लिखो उस चैनल का, कुछ डिस्क्रिप्शन लिखो, स्टेटस को ऑन कर दो, इतना काम करना है बस जस्ट। उसके बाद जो इंपॉर्टेंट काम है, एपीआई कीज, एपीआई एप्लीकेशन प्रोग्राम इंटरफेस। अब मेरा काम क्या है, मैंने अपने प्रोसेसर से, कंट्रोलर से डाटा को राइट करना है, कहाँ पे, क्लाउड पे। किस डाटा को, जो एलडीआर का आ रहा है। एलडीआर से क्या इन्फॉर्मेशन आ रही थी, कुछ रॉ इन्फॉर्मेशन आ रही थी, वोल्टेज या वो सिग्नल, उसको मैंने लिखना है, कहाँ पे लिखना है, क्लाउड पे। तो मुझे सबसे पहले तो, अगर आपको याद हो, हमें क्या चाहिए था, यूनिक आइडेंटिफायर। अब पहले तो मुझे उस चैनल का आइडेंटिफायर पता होना चाहिए, कहाँ पे लिखना है। तो 2 चीजें हैं, एक है राइट एपीआई की, रीड नहीं हमें करना, हमने राइट करना है, रीड अभी नहीं कर रहे हम। एक राइट एपीआई की वहां से हमको मिल जाएगी, जो यूनिकली को जनरेट करेंगे आपके लिए, और एक चैनल आईडी मिल जाएगा। जब आप क्लिक करोगे ऊपर एक चैनल आईडी की ऑप्शन आएगी, राइट। तो मैं प्रैक्टिकली दिखा देता हूँ आपको जब करूंगा, राइट। 2 चीजें आपको चाहिए, चैनल आईडी एंड राइट एपीआई। उसके बाद का क्या काम है, आपको लाइब्रेरी इंस्टॉल करनी है आर्डिनो में, थिंगस्पीक, फिर मैनेज लाइब्रेरी में जाओ, राइट। ये वीडियो रिकॉर्डेड है, आप दोबारा से भी देख सकते हो। मैनेज लाइब्रेरीज पे जाओ, इंस्टॉल करो थिंगस्पीक, जैसे हमने पहले ESP8266 करी थी ना इंस्टॉल, इसी तरह थिंगस्पीक करनी है। अब क्या करना है मैं दिखाता हूँ आपको। आई होप इट इज क्लियर एवरीवन। कुछ नहीं किया, सिर्फ एक साइन अप किया है, उसके बाद एक चैनल बनाया, चैनल का आईडी नोट किया, राइट एपीआई की नोट की, और लाइब्रेरी इंस्टॉल कर दी थिंगस्पीक की, इतना काम किया, राइट। अब आते हैं दूसरे सिस्टम पे जहां पे हमने प्रैक्टिकल करना है। पहले मैं कोड समझाऊंगा, फिर क्विकली मैं आपको उस पर डालना सिखा दूंगा, राइट। I think there is some bandwidth issue. Just a minute. I hope you are getting my screen.
Yes, sir.
अब देखिए वही चीज है, अब मैं वाईफाई बोर्ड का यूज कर रहा हूँ क्योंकि मुझे इंटरनेट के साथ कनेक्टिविटी करनी है, राइट। सो 82 ESP8266 लाइब्रेरी, एक वाईफाई क्लाइंट, क्योंकि मैंने हॉटस्पॉट के साथ कनेक्ट करना है, तो मैंने एक वाईफाई क्लाइंट बनाया। थिंगस्पीक क्योंकि वो थर्ड पार्टी लाइब्रेरी है। अब मैंने ये अपने हॉटस्पॉट इस मोबाइल फोन का मेरा जो हॉटस्पॉट है मैंने वो टर्न ऑन कर लिया, राइट। इसको मैं लाइट बंद करूं पहले। इस मोबाइल फोन का मैंने हॉटस्पॉट ऑन कर लिया, उसका जो SSID है, जो यूजर नेम है वो ये है, और इसका पासवर्ड ये मैंने इसमें डाल दिया। क्यों? क्योंकि मेरा जो वाईफाई बोर्ड है, ये जो मेरा कनेक्शन है, राइट, नोड MCU का, इसमें जो ESP8266 है वो मेरे हॉटस्पॉट के साथ कनेक्ट करेगा। क्यों? क्योंकि उसने इंटरनेट पे डाटा डालना है ना, क्लाउड पे। तो मैंने ऑटोमेटिकली ये भी मैंने करेक्टर कर दिए डिफाइन, ये करेक्टर कर दिया SSID जिसमें ये इनपुट है, एक करेक्टर कर दिया पासवर्ड, इसमें ये इनपुट है, ठीक है। अब मैं उसको यूज आगे करूंगा, ये ग्लोबल वेरिएबल बना दिए मैंने कि मैं कहीं पे भी यूज कर सकता हूँ, राइट। अब एक इंटीजर वेरिएबल लिया, ये करेक्टर थे, ये वेरिएबल था, ये भी वेरिएबल था। अब वही वाला काम, ए नोड पिन से मेरे पास डाटा आ रहा है, इफ यू रिमेंबर, एनालॉग पिन से LDR का डाटा, उसको मैंने एक वेरिएबल में डाल दिया, इसका नाम रख दिया LDR पिन। अब इस लाइब्रेरी से मैंने एक क्लाइंट, एक ऑब्जेक्ट बनाया क्लाइंट नाम का, ठीक है, इसको आगे यूज करेंगे। अब ये चैनल ID और ये वो राइट API की वही है जो हमने वहां पे से उठाई है, थिंग स्पीक से, ठीक है। ये मैं भी आपको दिखाता हूँ कहाँ से उठाई है। तो दो चीजें हमने डालनी है, बस इसका काम इतना है कि ये दो पैरामीटर यूनिक आइडेंटिफायर है, किस पे डाटा क्या करना है, राइट करना है विद दिस की, और कहाँ पे राइट करना है, इस चैनल पे, राइट। वॉइड सेटअप में हमने वही सीरियल बिगिन किया, फिर कर दिया वाईफाई को करना है ऑन। अब मेरा हॉटस्पॉट कनेक्ट होना चाहिए ना इस बोर्ड के साथ, तो इस बोर्ड के साथ कनेक्टिविटी के लिए क्या किया, उसको यूजर नेम दे दिया कि मेरे नोड MCU ने किसके साथ कनेक्ट होना है, इस हॉटस्पॉट के साथ, इस पासवर्ड के साथ, और थिंग्स कीप के ऊपर वो राइट करना शुरू करते हैं, ठीक है। अब वही वाला लूप कौन सा चले, एनालॉग पिन को इनपुट किया, डिलीट कर दी। अब ये लाइन बहुत इंपॉर्टेंट, ये ध्यान से देखो, इसके ऊपर सारा वो राइटिंग चलनी है। अब यह क्या करना, माई चैनल नंबर, मेरा चैनल नंबर मतलब जो मैंने ऊपर डिफाइन किया था, कौन सा, वो यूनिक वाला जो मैंने थिंग स्पीक से उठाया है। माई चैनल नंबर ये है, माई राइट की है, राइट। तो मैंने क्या किया, इस पे राइट करो, ये डिफॉल्ट 1 है। क्या राइट करना है, वैल्यू। वैल्यू कौन सी, जो मैं LDR की वैल्यू निकाल रहा हूँ, जो मेरे पास रियल टाइम पे डाटा आ रहा है, वोल्टेज या जो भी आ रहा है, ये राइट की जो एक यूनिक आइडेंटिफायर है, ठीक है। अब मैं इसको स्टॉप करके आपको थिंग स्पीक ओपन करके दिखाता हूँ, जस्ट अ मिनट। I hope my screen is visible.
Yes, sir. Visible, sir.
अब ये मैंने, मेरा बना हुआ अकाउंट आप इजीली बना सकते हो फ्री ऑफ कॉस्ट। तो 1 साल, ये अगेन ये मैथ वर्क्स का है जिन्होंने मैटलैब बनाई है, राइट। अब देखिए वो, जब भी मैंने अब नया बनाना, आपने माई चैनल्स, मेरे आप चैनल देख सकते हो, मैंने वैसे ही कुछ चैनल बनाया, लाइट डाटा आपने बनाया है, गो टू न्यू चैनल, यहाँ क्लिक करो, बना दो, न्यू चैनल पे जाओ, वही चीजें आप नाम रखोगे, कोई कुछ करोगे, हो जाएगा। मैंने बनाया हुआ नाम रखना है, डिस्क्रिप्शन लिखनी है कुछ भी, और स्टेटस ऑन कर देना नीचे, शो स्टेटस, ठीक है। मैंने बनाया हुआ है, उसका नाम रखा है मैंने LDR डाटा। मैं क्लिक कर रहा हूँ इस पे LDR डाटा पे। अब वो चैनल ID क्या था, 1884 जो मैंने डाल रहा था, राइट। API की कहाँ से उठाई थी मैंने, API की क्लिक करूंगा, दिस इज माई API की, ठीक है, इतना काम है। मैं प्राइवेट व्यू में जाऊंगा। आप देखिए ये मैंने एक कल एक्सपेरिमेंट करके देखा था, मैं इसको क्लियर करना चाहता हूँ ना, तो मैं अभी रियल टाइम का डाटा उठाना चाहता हूँ। तो मैं क्या करूंगा, इस पे गया, ये एक्स एक्सिस वगैरह आप डिफाइन कर सकते हो, चैनल्स पे गया, माई चैनल्स, नीचे एक होगा क्लियर डाटा करके, इसमें चैनल सेटिंग, राइट। वंस यू गो टू चैनल सेटिंग, आप यहाँ पे ये क्लियर चैनल है, मैं दोबारा से स्टार्ट करना चाहता हूँ उसका, राइट। तो मैंने क्लियर किया चैनल को। अब देखिए वो ब्लैंक हो गया होगा वहाँ पे, तो प्राइवेट व्यू ब्लैंक आ गया, सी ब्लैंक है ना। ये मैंने खुद डिफाइन किया कि इस तरफ वोल्टेज है, इस तरफ डेट है या कुछ, अब मैं स्टॉप शेयर करके मैं दोबारा से वो कोड आपको दिखाता हूँ और मैं अपलोड करता हूँ। ये कोड मैं अपलोड कर रहा हूँ, ये कोड वही वाला जो मैंने आपको दिखाया था। So it is compiling. It will take couple of minutes क्योंकि वो डाटा पहले वाईफाई कनेक्ट होगा, वाईफाई के थ्रू क्लाउड पे राइट करेगा, राइट? So it is compiling the sketch. Once it would be uploaded, we may see it on the cloud. वो क्लाउड से आप दुनिया के किसी भी कोने में बैठे मेरे LDR का डाटा देख सकते हो और उसको एनालाइज कर सकते हो। So similarly for अगर आप मैं खेतों में काम कर रहा हूँ, मॉइस्चर का डाटा, कोई क्रॉप का कुछ सेंस करना है, कोई और जो भी आपके पास सेंसर है, आप देखिए अपलोड हो रहा है, राइटिंग एट डिफरेंट थिंग्स परसेंटेज वाइज। अब ये एड्रेस है, बेसिकली डिफरेंट एड्रेस पे वो राइट कर रहा है। So it is done with uploading. Now we can stop sharing. I'll show you the another one. इसको मैं रिफ्रेश करके देखता हूँ, is it able to write? Just a minute. ये क्यों नहीं राइट कर रहा? पता क्यों नहीं राइट कर रहा? क्योंकि मैंने अपना हॉटस्पॉट ऑन ही नहीं किया, राइट? So this is again a technical problem. So I'm turning on my hotspot. So just one more thing. अब मेरा लैपटॉप भी इसके साथ कनेक्टेड है, राइट? तो आई थिंक देयर वुड बी सम जो कनेक्शन लॉस्ट होगा जूम का भी थोड़ी देर के लिए। जस्ट अ मिनट। It will work now. Now check. What is the time today? 17:05 5 मिनट के 2 मिनट पे डाटा आ गया, राइट? अब मैं क्या करने जा रहा हूँ, मैं फिर अपना फोन ऑन करके लाइट ऑन करना चाह रहा हूँ ताकि मैं आपको वेरिएशन दिखा सकूं LDR के डाटा में। तो मैंने फिर टॉर्च ऑन करी है, राइट? अगेन शोइंग इट टू दिस, राइट? सेम सर्किट, थोड़ी सी डिले है, वो देखो एकदम से आप शूट हो रहा है, राइट? दिस इज माय LDR, राइट? अब मैं वोल्टेज नहीं प्रोड्यूस कर रहा, मैंने रॉ सीधे A0 को उठाया। अब मैंने उसको 5 वोल्ट के साथ मल्टीप्लाई नहीं किया, ना ही 1023 के साथ डिवाइड किया। चेक करो, इज इट विजिबल? आप देखो एकदम से शार्प पीक। जब तक लाइट रहेगी वो कांस्टेंट इसी पे रहेगा। नीचे देखो टाइमिंग भी आ रहा है, रियल टाइम है। रियल टाइम में देखो 5:03 पे उसका डाटा जो था इंक्रीज हो गया। अब वो कांस्टेंट चलेगा क्योंकि मैं लाइट कॉन्टिन्यूसली डाल रहा हूँ। फाइन। अब मैं दोबारा लाइट हटा दी मैंने, अब मैंने उसके उस LDR के ऊपर हाथ रख लिया ताकि वो ये फील करे कि डार्क है। अब देखना इस अब्रप्ट डाउन आएगा वो, क्यों? क्योंकि उसके पास अब डार्क आ गया। अभी वो पिछले वाला डाटा उठाया उसने फिलहाल। तो देखिए साथ में वोल्ट डेट टाइम भी आ रहा है। 15 सितंबर को कितनी वोल्टेज थी, कितना कुछ था, आ गया नीचे। क्यों? क्योंकि मैंने LDR के ऊपर हाथ रखा है, राइट? सो दिस इज द ब्यूटी, मीन्स रियल टाइम में। अब इसके ऊपर आप क्या है, साथ में एनालिसिस करना है, एनालिसिस भी कर सकते हो आप डायरेक्टली। यू कैन क्लिक ओवर मैटलब एनालिसिस। क्या चीज़ चाहिए आपने, एवरेज रेंज निकालनी है, हायर लोअर निकालना है, वो इनबिल्ट है आपके लिए। कुछ कोड करके आपने और चीज़ में मैटलैब में लेके जाना है। सो एवरीथिंग इज पॉसिबल, ठीक है? तो स्काई इज अ लिमिट। जो आप सोच रहे हो वो आप कर सकते हो, राइट? अगर आपको लगता है कि कोई चीज नहीं हो रही, डोंट लीव इट इन बिटवीन, राइट? बस उसको करते जाओ, ताकि ये ना हो कि जी हो नहीं रहा, नहीं हो रहा, आज कल परसों करते रहोगे आप, राइट? देन अल्टीमेटली वो होगा ही होगा, मेरी हेल्प से, किसी और की हेल्प से, यूट्यूब वीडियो से। पर ट्रबल शूटिंग इज द मोस्ट इंपॉर्टेंट पार्ट। हम कई बार घबरा चलते, चलता तो है नहीं, क्यों नहीं चलता, दैट इज द मेन रीजन यू नीड टू फाइंड आउट, राइट? So winding up, summary, today we did IoT introduction, components, architecture. Cloud में नहीं ज़्यादा बता पाया, but again if Vishal sir, director sir will again give me opportunity, definitely I'm certified AWS expert, so I'll give you one whole presentation on AWS cloud, right? Then we did Node MCU, demonstration of Node MCU using cloud, right? Maybe we can also plan it for other series using various other sensors. Blink app, there is one mobile app, Android app, through which you can control devices, right? IoT based home appliances demo, and that's it. So that's it from my side. I hope you have learned something out of this workshop, right? If not, try to bring that toy at your home and try yourself. So it is very interesting, believe me. Thank you.
Okay, that's very beautiful, sir. Very informative session, I think. सभी बच्चों ने enjoy किया होगा, सभी participants ने. So I request all the participants, if you have any doubt, you can ask your questions regarding this session. You may raise your hand. Sir, I have one question that regarding this. You said that things speak, that is a cloud. Is it a free of cost?
Sir, like 3 channels are free, as per my knowledge. 3 or 4 channels are free. If you want more channel, like for example, if you are taking data from say moisture, you are taking from light, you are taking from other signals, till 4 it would be free. More than 4 it will be paid.
Okay, then it will be a chargeable.
So even like you can put data on AWS also, on Google also. So number of platforms are there. Maybe next time we can have multiple clouds or cloud also, cloud presentation, cloud workshops, in which we can have practical demonstration how you can make servers over the cloud and so on.
Okay, sir. One more thing, sir, that can we control the devices?
Yes. So see, we are sensing and we can send even actuating signals as well. So after analyzing, say, if I want, again, that same example, so we are sensing the moisture from the field, and if we want that motor should be on or off. So based on that data analysis, after that data analysis, we can send that signals also.
Any other questions, students? Please raise your hands. Any question, you can even type in the chat box. So I'm also sharing a feedback form, students. Please write, somebody is writing that a very interesting and informative session. Yes, well said. Indeed, it is a very interesting and okay. If any questions, you can type. Any doubt? Even we can share Anurag sir's PPT with you.
Yes, definitely. I'll share it with you.
Okay, I think it's okay from the participant sides. Pathak sir, over to you, sir.
Thank you, sir. It was really very wonderful session, sir. It was very interesting and very informative.
Thank you, sir. Thanks a lot.
The video of this will also be available on our YouTube channel. Students can also see that, download that video. And also the PPT can be also shared through Vishal. So I think Vishal, now it's time to have a vote of thanks. You can please continue with the vote of thanks.
Thank you, sir. Thank you very much. So good evening to all. My greeting on this special day. Happy Engineers Day. First of all, I'm very thankful to Dr. Anurag Sharma ji for giving us an inside view of IoT. He explained very well in a very simple language. I think even a layman can understand all the things. And you discussed about the future and current status of IoT, and also discussed some challenges. Some of the examples you have shown us that IoT waste management, it is really a wonderful example of IoT. Smart Bin, and you have also discussed challenges. So I request all the participants that the challenges part, it's very important for us so that you can take up in your project work that challenges, because as Rag sir told that connected person per devices, so they are keep on increasing. As we know, the population is keep on increasing. So we need a backup, that platform which is very solid, wherein each and every user can join easily and send data to that cloud. So that is a challenging part. That challenges can be your future topic in project works. Further, I would like to say that there is an innovation hub in our science city. These Arduino coding, you can learn from this. You can be a member of this innovation hub in our science city. It's very affordable prices of innovation hub. You can register yourself as an innovation hub member and can learn this Arduino programming. After then, I would like to thank, I'm very grateful to DG ma'am and director sir for their continuous guidance and support in organizing such wonderful sessions. In the last but not least, I thanks my officer, scientist engineer Ritesh Pathak sir for giving me motivation in conducting such activities and giving me free hand. And I also thanks my supporting staff for conducting this event. I request all the participants that you must subscribe our YouTube channel also. And we continuously organize such programs for you. Keep in touch with us. You have, I think, contact number of me and Anurag sir. If you have any doubt regarding IoT, you can contact Anurag sir, or even you can call me. So thanks a lot. Thanks to all the participants. Thanks, director sir. Thanks, Pathak sir again. Thanks, Anurag sir.
Thank you, sir. Thank you, director sir, Pathak sir, and Vishal sir for having me here. I hope I would be able to, convey some of the information of IoT to the students, because I tried that it should be in the single language and it should be the basic one, and then only student can enjoy. So once student enjoy everything, then they start learning. So it's that's it. So thank you for everything, and I hope I must fulfill even your wishes of all the things which you wanted to convey to the students. Thank you.
For a wonderful session. Thank you very much.
Thank you, sir. Thank you, sir. Thank you so
Thank
much.
you, sir.
Pleasure in mine, sir.